whoever is seeing this, welcome to the lounge. Alrighty, let's get right into it. Welcome back to the lab. Let's see. Last time we kind of worked on a day-night system in a way. So let's just show that off real quick. So we have our game controller over here. This is going to be where all our controllers are. We have a wave controller. So here we can kind of see some of these spawn points. Some thoughts I had is maybe creating more for a different area. This would space them out. For instance, we're only setting it to a random of 4 or 3, I think it was, where it's like a 1 in 3 chance to choose from different spawn points. So sometimes we'll get them going from different areas, but a lot of times they do actually just go from the same point. So instead, if we put like 3 points, it would space them out. So if they do go from the same point, they would be walking in kind of a different line instead of just being kind of single file, which is always a little weird, but that's something we can do in the optimization phase. So how this works, we got some spawn points. These are static objects below in our wave controller. Yeah. So they will spawn at spawn points at at its position. Then we have a day-night controller here, which is basically very simple. It took us a while to figure out how to get the rotations working, but basically it rotates our sun object, which is that, over until it reaches -90 degrees, which is pitch black of night. And then once it's pitch black at night, we set a variable is day in here to false, and in wave controller, that's where this is tied to that. So we could even tie it somehow differently, but I'm not going to right now. And it will set an is night in here equal to the opposite of is day. And once it is night, and other specific things are met, it will start the waves. We have a max enemies per wave number right here. The spawn delay in between, like that's the time in between when zombies are spawning. So that could eventually be a variable time. So we could have like some flexible stuff, but right now it's static. Then we have, these are actually just serialized field. These are supposed to be private. These are just for debugging purposes. Spawned enemies and active spawn points, because I don't want all the spawn points to be active every single time, because then they'd be coming from every single direction every single time. So what my thought process is that we select a point in the list, and they go in kind of a circle in this list, and basically we set a number, and active spawn point is going to be basically that spawn point that is randomly selected, and then the next ones in the list up to its points. So for instance, if we choose this one, if we had 3, it would choose this point, and this point, and that's the points that could be randomly chosen for the zombies to spawn at. And the next wave, maybe it chooses this point, so it chooses this point, that point over here, and that point right there. Next up, spawned enemies. That is actually just keeping track of the enemies that have spawned in our scene. We call an spawn enemy function to instantiate a zombie prefab at a spawn point. And then we add that to this list. And how we know the wave is over is basically that spawned enemies list is then 0, because it is constantly checking for if there is a enemy alive. So once an enemy dies and it's not alive, we said its damageable component is alive. We're constantly checking our spawned enemies, and if it's found to be dead, then we remove that from our spawned enemies list. And once all the enemies are removed, we simply acknowledge that the wave is over. Then we have a wave number counter. Pretty simple, straightforward right there. Just increments the wave. When the wave's over, we have like a 10-second delay using a numerator function. Probably a better way to do that, but that's okay for right now. And yeah, basically, every 5 waves too, it will activate the day. Eventually, there might be something cool happening during the day that that will stop during the daytime for. But for now, we just have a set time, daytime in seconds, and then we have a night to daytime. So when the wave ends, we have a amount of time to where the sun starts rising, and then it activates the daytime. Basically, this is just another function basically calling start day once we reach wave 5, or after wave 5, I should say. And yeah, so that is basically what we set up last stream, this time controlling system. Let's go check out how that's working. So right now, we'll only have three zombies per scene with a minute space between them. You'll see a wave number right up here. Pretty cool. So daytime's happening. During this time, the player could be preparing, setting up barricades, shopping, buying new weapons, kind of doing anything. 60 seconds is just a placeholder value. In fact, I probably could have done 10 seconds. But if we go to the sun, we can see that this is rotating like so. So this is about to start setting. And this will, of course, reach our desired value because we're lerping it by the time it's done. We can see it's setting pretty quickly. So the shadows are looking a little funky, of course. We don't have like any actual barriers out here that like would make it look too crazy. But slowly but surely, the shadows are going to take over because it's going to be the dead of night soon. Here we go. -90. And we can see some zombies spawning in here. If we go to console, we can see that we're debugging some stuff. So the enemies have been spawned, and they are pathing towards this goal object. All right. They should be heading here. I mean, they're not too quick. Don't really know where they're coming from. Usually they'll probably come from this direction because there is only one spawn point back here, but you never know. We check our scene. Yep, here they're coming. Like so. Okay, slap them. And right now I have this weapon set to basically doing as much damage as their health. The combat will definitely need to be reworked. All right, so we can see here, I killed them all. Wave is finished. If we go to wave controller, spawned enemies is 00 was updated, basically like so. Now we only have 3 more. These are the new 3. The bodies are static game objects, but we do have set it to disable their colliders when they're dead, so that won't cause any funky game mechanics. But yeah, here active spawn points, we have 4 of them. This should be selecting a random position out of them for spawning each enemy at. But of course, using Unity's random function can cause some variable fluctuations, so we'll see what happens because they do all come from the same area usually. So we'll have to investigate a little deeper in there. Killed them both. Another wave finished. So it starts a timer, 10. So these are still here because we haven't cleared them out yet. But once the timer increases, wave number increases, that will clear them out of the spawn enemies list. And then the new ones settle in. And the reason why we were doing that, it was just causing a enumeration problem. So we needed to wait for all of our basically wait for seconds functions to stop before anything can happen. So we're gonna keep waiting here. This guy's bodies just chilling. Slap him, slap him, slap him. All right, wave is finished. So we'll wait 10 seconds, and that's gonna be able to be set variably, of course. And then wave 4, clear the wave. Wave is handled like so. And they're going to keep coming. Let's see where they're coming from now. They're coming from the same spot, so that is definitely something to investigate, why their positioning is not being randomly set. What we can always do is have a static position, so it selects a random point in the active spawn points and then just goes through the list. like so for each enemy. Just increases the list by 1. All right, they're dead. Wave is finished. Wait 10 seconds. Just a little bit of downtime in between waves. Of course, we don't want to overload the player by having the wave increase right away and spawn the zombies right away. So some more zombies spawn. I imagine they're coming from the same spot. Yep. Okay. I know where they're coming from, so I'm just gonna run towards them. I would slap them. And there, wave is finished. So, after 10 seconds, what we should see happen is the day is gonna start rising. Okay. So wave 6 increases, because we increased the wave number, and it's daytime. So we got some new active positions set. That should also be setting before every single wave. I'm at half health right now, because the zombies do hit pretty hard and haven't really balanced it yet. So now daytime is happening. We just hit peak day. It's setting again. This is going to give us a minute of downtime right now. Basically to prepare if we had some other of the implementations. Also during daytime, this is when the zombie bodies are going to be cleaned up. So we'll just basically, I'm thinking when we remove these zombie objects from the list, what we can do is actually place them in a garbage collection like game object. And then during the day, just activate like the garbage collection, like remove bodies function, and it will remove every game object that's dead. All right, so there we go. Day is over. Night just begun. Wave 6 has officially started. We're probably gonna hide the wave number during the day because it does increase statically. So let's just see how far I can make it. And of course, in the future, more zombies will spawn, different types of zombies will spawn, but right now we have our basic placeholder zombie, which is literally a green version of this free little model I got. So, doing a little kiting, not too bad. In the future, I might make it so... We gotta make it so the zombies, when I leave their attack zone, stop attacking, maybe. Or something like so. Their attack hitboxes are a little big. That's for attacking this thing. This actually does have an object and actually have health, and eventually what we're going to basically do is with that object have something tied to its stand control component, and if its stand control component is too low, it's going to break and stop doing what it's supposed to be doing. But as you can see, there's a pretty big amount of zombies in our scene right now, and here they come. I'll show off exactly. So I have it set to where if I leave their AoE, they will path towards this goal. So for instance, if I run pretty far away, probably actually won't be able to see it. Yeah, you can see they kind of start moving that way. It's a little bit finicky like that, but there's one. So we're gonna slap these guys, and he's going and attacking that, so we're gonna slap him as well. Wave is finished. And then after that 10 seconds, our wave number goes up. And yeah, so what I want to test is, let's see. We're going to basically set, so our wave is handled, so this won't affect anything. But if we set that to 10, the next round, we're going to get 10 zombies and see where they spawn from. Some just little testing, see how our systems are working right now. I'm at half health still. I'm imagining they're coming from here. Yep. Let me just smack these guys down like so. Hit me once. Wave is finished. Wave number 8, we should see this spawn enemies list clear out, and we're gonna get 10 more zombies. All right, 1, 2, 3, 4, 5, 6, 7. Okay, yep, working all good. Let's see where they're coming from. They are all coming from the same position, so that definitely means something finicky, something weird's going on here. So if I click these, it is actually going to all the same spawn points. So that does look a little weird. The active spawn points is actually probably the problem. It's only setting it to the actual same spawn point, which is weird. But yeah, I just want to see basically how many zombies. All right, wave finished. Wave number 9. Okay, sweet. We got another 10 zombies spawning. like so. And of course, we want the spawn point to be outside of where the player can actually like reach. So eventually we'll have like maybe an invisible barrier or like a actual barrier there that the zombies can get through, but the player cannot. Just kind of like how Call of Duty Zombie does their windows. I have 1 health. Let's see if they can even get me. Oh, there we go. And then when we die, our death menu pops up. These guys are still walking towards us, attacking. Of course, they're not going to try to attack me, the new ones anymore, but my collider's still there, so they can't walk past it, and I'm still set to their thing. Okay, cool. So, let's just go ahead and dive into the code. Let's go into our wave controller, and we're going to need to set active positions. Well, active is less than or equal to the amount of positions. Okay, so this is very easy to fix. We're basically just going to make sure that would make sense. So random index, we don't actually even need to be setting that right here. We're going to basically just set this equal to 0 right there. And in here, we got to, of course, set it to the range. Random index. Actually, this is where it should be being set. Is +1. So yeah, wait, never mind. I was handling that. So let's see what happens. So that must be the 0th point. So if random index +1 is less than spawn points dot count -1, then it should be a random index ++. But if not, then we set it back to 0. So we're gonna just do a little debug .log active position equals, and we're gonna literally just do an active, or we're gonna do a spawn points at the random index, or we're actually, no, we're gonna do random IDX. Random IDX equal to a random IDX. Like so. And see how this goes. All right, response. Okay, this doesn't seem to be doing anything crazy, but whatever. We're gonna ignore that because that's a package manager window, which I don't even have open. We're getting a request error. Okay, so random IDX has always been 2 here. So is less than spawn positions dot count. So maybe this. I could always be doing this wrong. Because that would make sense why they're not actually changing any of their random positions, because there's only one set active position. All right. Zero, 0, 0. Okay, so they're all 0. So that's not working. So let's go. I'm always a little confused with this, how this stuff works. The inline booleans work. Equals random IDX +1. That shouldn't. See, this should always be increasing. So random equals, if that, then it's random IDX +1. And that should just be a ++. But why was it never increasing? Why wasn't it increasing? Is my question. If not, we're going to remove this inline because, I mean, it should be working. I want it to be in line, just, you know, coding sake. 1, 2, 3, 0. Okay, there we go. So that was the problem. So now if we wait, I'm going to set this 10 as well. Because they won't even check until it's actually handling the wave and the date is over. So don't want to update that, of course. I don't know, during actual wave spawning, that can cause some very finicky things. But now we actually have differing spawn points. So we should actually see the zombies now be spawning from different random locations. And we're going to watch that happen in real time. So maybe in the inline Boolean, not having a plus plus is the way to go. All right, here we go. Spawning enemies. Yes, we are getting them in a random location now. You can kind of see that happening. Of course, they'll spawn in some of the same locations because we only give it a couple of points. But there we go. Look at that. Spawned in different locations. We go to their game. We should see them variably come here. All right, smack these guys down. And like I said, this is where our actual weapon would not be dealing their whole health. And for instance, if I walk in there and attacking, they're gonna attack like that. But they do keep moving while they're attacking, so that's something to look. Oh, we got something weird going on here. He's falling back. Definitely some bugs we're gonna have to look out for. Okay, once I went outside, interesting. All these guys go towards there, and because they are attacking, oh, look at that. They're like, nope, don't attack me. Okay, dead. What about you, guy? Yeah, so you are glitched. Oh, and I'm dead. Yeah, so that's something. There's a little glitch going on there, so we should maybe investigate that sooner rather than later. But for now, I think might not tackle that right now. Let's see what is on the agenda today. Yeah. We have a couple of options we can choose from here. We got currency, placeable objects, snapping in a grid, only placeable in diner, obstacles, per placed, purchasable, and max amount set. Few exceptions that will go outside. But yeah. So let's think. We do currency for buying things, but I think we would actually want stuff to buy first. It's always a tough choice. Well, I think it might be time to do some placeable objects, and these, of course, are going to be placeholder objects, probably some cubes and such. So, placeable objects. This is going to require some probably hefty things. It might be a multiple day type of thing. But what we're going to basically need to do is select areas within our diner that is going to be allowed to have placeable objects. So maybe in our kitchen, this is a static environment. Can't move around some things, maybe specific things. We could have specific objects that are only allowed to be placeable in different zones of the diner. So for instance, maybe here is some thoughts. We have tables, chairs, and all that in our diner. We'll have a countertop. We'll have like some machines as well, not just a waffle machine, which is the goal. Maybe like a soda dispenser and whatnot. But we need it to be in a specific area. And for instance, we don't want counter elements to be able to be just basically placed anywhere. For instance, like we may have to like have a starting area, like a starting counter area, which you can expand upon or move around, but they have to be connecting to a specific place. For instance, we don't want the player to just also be able to barricade up the doors. Maybe we want to be able to do with our like tables and whatnot, but we can't do it with the counters because the counters. So this is going to be some game design choices right here. So let's go ahead and actually plan this out. So let's see. I'm actually just going to go ahead and pull up. And here, let's create, not material, scripting maybe. No, not assembly. We don't want assembly. Just go ahead and plan this out. All right, so placeable objects. What we're going to need, snapping in a grid. Okay. So, if we're planning this out, we're going to need some needs. We're going to need a grid with sections. And we're going to call this maybe kitchen. Behind counter, BC. Ahead of counter, AC. Or we'll do behind counter. Dining area. And then maybe like storage / bathroom area. So if we want to think this out, we could eventually, I'm going to make a little section over here, probably just like bathroom, storage, that type of stuff. Probably have some doors or a window, like not in the bathrooms, of course. But something like a way the zombies can go that way and is kind of unexpected. And whatnot, and just make our environment more, you know, kind of realistic in a way. Even though it's going to be kind of a wacky arcade type of thing right now. That's how that's going. So, like, for instance, if we want to actually just use this line, we could imagine everything past here is our area that is, like, zoned off. I don't think we'll be able to place anything in our bathroom area because we don't... We'll probably will. Maybe move some... Maybe we'll be able to move tables in the bathroom area. But let's actually focus on this. So, dining area, that's going to be our big one. That's going to be... Let's say if I were to just create a empty 3D object. We'll call this just a cube. So, drag that down. It was a lot higher than I thought it would be. Let me just delete that. Okay, so let's say like this whole L-shaped area is our dining area. We'll have tables set up and chairs. And also, so what we can do is maybe allow the player to grab them and move them around to create some barricades in front. The tables, maybe they need to be actual barricades. That zombies don't just climb under or something. They be flipped over, and then the zombies have to break them to get through. You could create like a maze like that. That allows you to use maybe a ranged weapon to hit them down, or maybe you just like block them off to delay them in, but eventually they're going to break those tables, and maybe you have to buy more tables to add some complexity. So you have to generate a good amount of currency to replace the things you've broken and whatnot. So that's kind of the idea there. Behind the counter section, we'll have our like goal objects and some useful objects that we might use in the game. Like maybe we have a healing station back there. That's where you refill your healing stuff. Maybe that's some of the things that generate currency during the day. And whatnot. But yeah, so that would have some placeable things that are only allowed to be placed there. So we got to think about zoning off kind of an area. I'm imagining here I'm going to have to zone it off manually. I'm not going to automatically generate it based on the kind of layout. I'm thinking that this game is not going to have like procedurally generated maps or anything. They're going to have static levels. It just makes it a little easier on me. I don't have to worry about generating zones and such. We need these zones to be kind of in a grid format, so we'll have to basically create an object that spans the length of it, these zones, and from there maybe create a grid out of that, kind of like how the nav mesh works. And from there, those are going to have to be cubes, and each placeable object is going to have to take up a certain amount of cubes, because we don't want any overlaying stuff. Maybe we want stuff only being next to each other in a certain amount of space. So there's some forethought there. So we'll need if we go back to our design doc, well, for placeable objects, we need a grid with sections, kitchen, dining area, all that. And then I want to be able to flush out these ideas so we know what we need. And that's not going to be right here. So let's start high level, and then we'll go flush out the ideas. Certain objects able to be placed in certain sections. So for instance, tables in dining room, counters in specific places. We'll say machines in behind counter, and maybe just we don't have to worry about anything else for there, because once we make this basic system, we should think about it component based, where we have to apply basically when you give a placeable object, you can give it a area that it's allowed to be placed in, and from there that's where we're allowed to place the object. And if it's not hovering over that area, then maybe it goes transparent, or it goes red or something. You can kind of get the idea there. So certain objects able to be placed in certain sections, tables in the dining room, counters in specific places, and machines in behind counter. That's all we really need for that. So this is kind of really kind of what we need for the placeable objects, right? Am I missing anything? Grid with sections. Okay. So that is our needs, but I want to be able to flush this out. So actually, what we're going to do is to flush this out is we're going to definitely need a placeable object container. So in our game controller, in our map, actually, this map is our generic thing with tile objects, and these are all going to be prefab props. Yep, so that's in here. So props is just some general stuff, like we're not going to be able to place trees down. Like this fire hydrant is just there for looks. In fact, it's not even noticed as a obstructable. So let me just put that on that layer, and I can always rebake the nav mesh. But yeah. Let's see here. Okay. So here we're going to create an empty, and we're just gonna call this placeable object for now. Simply just because this is going to be just a basic game component, and this is going to we're not actually going to create a prefab. This is just something for testing. We're going to add a component. We're going to call this placeable object. Actually, I don't want to create that in there. I want to create it in here so we don't have to reload everything. So scripting, mono behavior, we're going to want this as a placeable object. Yep, like that. Okay. Have to reload, compile that. So we can apply that to our placeable object. I'm also thinking we're gonna need a what's it called? We're gonna probably also need in the scripting. We're going to need another mono behavior, and we're gonna call this let's think. Placeable zone. Okay, like so. So let's create another object, and we'll create a plane for now, like so. So this is just going to generically show us this, like, in a mesh kind of, so area where the zone is. Maybe we could make this mesh transparent, or maybe just for now it just is our representation. So let's put it kind of flush with the floor, like so. We don't want the collider on, because that's just, it's not actually going to be displayed. And let's make it kind of flush with this wall, like so. And go up. I'm going to create a material for this as well. Actually, we can just give that the red material. So plane, and we're going to call this placeable. Actually, not gonna. Yeah, I'll call this just placeable zone. Eventually, this would be probably called like dining area or something. Placeable zone, and we're gonna also have create empty. We're gonna call this placeable objects as a container, and placeable zones, and eventually we're probably going to move these into the map, like so. And if we go to map, we can see, we just have a nav mesh surface, and it won't affect anything if we just place that below hand. So let's go. We got placeable object and placeable zones. Let me go into this right here, and I'm just going to denote it as a red thing, because why not? We'll make it a little red, just to make it a little bit easier. And let me scale that. It's X a little bit, maybe -10, like so. It's a little big. Negative, or we'll do 5. Do 5. No, 3. Like that. And we'll just denote this as the placeable zone for now. This is the area. This will be the dining area, for instance, just for testing. In fact, we probably don't want to actually have this as a measurement or as a mesh eventually. Or maybe we do. Because maybe we want this to turn on when we turn on like a building mode or something. When we're able to place objects, we have a alpha material. So if we go like to here in our red, and we actually set that like to a more of a transparent material, maybe it just like highlights the areas and has like a text going across it. So that could also be something. But let's go, now that we have some basic things, placeable object, we're going to add a cube as well to this. Not empty. We're going to create a little 3D object and cube, like so. Alright, and we're just going to be mesh. Like that. Okay? Sweet. Also, for this, we're going to want to have a nav mesh obstacle, shape, box, capsule. We'll be able to, that's fine. Carve. Okay. Let me also go back to the nav mesh. Unity nav mesh. Because I remember, not in that, we'll go and navigation, interface, obstacle component. Shape, center, carve. I should create a hole in the nav mesh. When selected, nav mesh carves a hole in the nav mesh. When deselected, does not carve. Specify time. So we're gonna want carve selected because this is something that we're gonna have move threshold, time to stationary, carve only on stationary. So that's pretty simple, because during the nighttime, I'm thinking I'm not going to want to be able to allow the player to move anything. So that's where that daytime kind of like setting up, kind of getting ready for the night to come comes in handy. Like, you're allowed to move stuff, but during the nighttime, you're like, all right, I got to focus on killing the enemies. You shouldn't be able to move anything during that time. So we have a setup time, and we have a actual battle time. So we definitely want to be able to carve the nav mesh with our object. So you can basically see how that works is it literally just like has a radius around it, sets it to being an obstacle. And actually, I don't want to move that because we want to move the placeable object, if anything, like so. So you can see how that works. So now, of course, the zombies would path around it. And what we could even do is give it like a weight or something, like make it a link to where if it's... I'm thinking a little too far ahead. So, of course, it's going to be an obstacle. So if we're blocking off this thing, right now what it would do is... basically, it would make it so the zombies would probably find another way in, probably go down here if we blocked it all off. Eventually, what we're going to want is them to actually, because these placeable objects are going to have a damagable component as well. So let me go ahead and or go ahead and add that, and the zombies are going to be able to attack it. And once it's basically destroyed, basically we're going to disable the collider, maybe cause an animation of the table breaking, or just simply deleting the object from the scene, and then allow the enemies to pass through. But yeah, okay, so we'll have a placeable zone like so. Placeable zones, placeable object. All right, so let's go back to our scripts, and we're going to really start fleshing this out. So let me add that to there and add that to there. So now we have placeable objects and a placeable zone. Okay, so I am thinking that maybe we're going to use this plane and get the dimensions of something. Or, what's the best way to denote zones? Let's look up some other examples. Unity, denoting zones in a map. Looking for advice on implementing multi-map/zone. I feel like duplicate multiplayer 2D RPG with multiple areas. For example, a grassland area and desert end. Two different players can be in two different zones. My first thought was have multiple scenes. A player's only in... Okay. Stack scenes and fish. We don't need all that because we're not going to actually... We're going to have one scene. Create clickable zones. Here we go. I'd like to know how to create clickable zones. And I'm working on managing a managing type game, and I lack experience when it comes to code. To use to move a character, rather a token on the map to interact with different tiles. I already managed to simple part token follow my clicks. No, constraint only in specific zones. This is actually probably a good idea. Okay, no one's answered. Oh, here's some comment. If I understand correctly, you have a click to move game and want to limit the clickable areas. If you are using nav meshes, you can use nav mesh sample position to create nav meshes of the area. You got the first part. I want to limit the clickable areas. Well, I believe it's a way to do it, but I didn't plan on using that much. In fact, I thought of using game objects with collider since I won't properly get a character to move as an in a RTS-like game. Thank you for your answer. I will keep searching. I suppose you could place invisible quads with a clickable tag to represent valid spaces, or if you want to get fancy, you could assign them to their own layer for ray casting. Yes, that seems to fit what I have in mind. In fact, they're pretty much everything I need at the moment. Could you lead me to this corresponding script reference, please? Once again, thank you. And look here, you need docs for layers. About half down there is an example of selective ray casting that should suit your purposes. Okay, so what it comes back to is, of course, probably being a collider. So if we enable our mesh collider on this and we have a convex, we can see that, and is trigger like so. So this is actually, it's going to be kind of like a grid area. So we can always, so the basic thought process is if we're going to go ahead and pull up these scripts like so, because we're going to want to start thinking some of this stuff out. Placeable zones and placeable objects. So a placeable zone, what we're gonna need is we need a object that can span an area or create a ghost area that does not escape our specified specified dimensions. So the easiest way, of course, for this, the easiest way I can think of is to use a plane that is not going to be visible. That denotes our area. We get its dimensions. Fill it with cubes. Cubes of a certain size that fill it with cubes of a certain size. Not cubes. Fill it with. We get its dimensions and create a grid inside of our zone. The grid layout needs to basically have a placeable tile object, and if those placeable tiles are not obstructed, spanning the objects, the placeable objects collider, then we can place the object. Okay, so we're thinking this out. So we need an object, expand an area, or create a ghost area that does not escape our specified dimensions. I don't think I want to specify the dimensions, because that's gonna basically how I would think about doing that is placing probably little points and just getting a transform location at that point and then creating a grid in that area. Where simply we could always just get a plain object like so, create it to our specified dimensions. For instance, maybe we have like, this is like a cooking area or something, or we can always move this back and do a 3.5 or a 4. No, not 34. 4. And that actually seems to almost span our entire area. And we probably want the doors more covered than the walls, because this is actually probably going to be an area that no one really steps over to. So we can always just scale this. You can see how big the object is. And we can also, I'm sure there's ways to actually go ahead and create this plane. Actually edit the mesh if we wanted to, and like extrude it, go in Blender. There's a lot of different things we can do, or we can also even overlap zones, because we're going to basically probably use tags. We're going to have a layer, probably placeable zones layer, and then have a tag for the certain zones, and then create a grid out of those objects, like basic like that. So now we have a certain area. We're going to basically need to grab the area and break it down into a grid. So if we grab our basic object, don't really know how big the actual table is going to be quite yet, but let's imagine we probably don't want the grid to actually be the size of a cube. Maybe we want it to be the size of like 4 of the grid spaces make up maybe one of these cubes. That will give it the player to actually have a little bit more like flexibility in how they want to place things, because if we just had it snapping like so, it would have to be like you couldn't create any spacing or whatnot. And yeah, why would we not want the grid to be the size of a specified like object and keep it all static? Well, actually, yeah, because objects can be different sizes. Like the table is not going to be as big as a chair. So basically, we want our smallest object to be the size of the grid, and we're going to want, of course, these things to snap to the grid. But we also want to have variable size objects. Like maybe we'll even have different size tables because we have 2-person tables and we have like 2 tops and 4 tops. And maybe the 4 tops are a little bit stronger because they're bigger tables, but the 2 tops are cheaper, or something like that. So there's something we can think about like that. Sorry about hitting the microphone there. So yeah, let's see. We go, we get its dimensions, create a grid inside of our zone, and we're just gonna call this mesh. The grid layout needs to be basically a placeable tile object, and if those placeable tiles are not obstructed, spanning the placeable object's collider, then we can place the object. Start is called, okay, so there we go. So first, what do we want to do first? Gonna need, on start, we're probably going to want a generate grid function. And from here, let's generate a method called private void generate grid. So in here, we're going to, using our zone object reference, generate a grid of placeable tiles over our let's say over our mesh. So also, let's see, because of course this is not actually scaled to be a perfect like size of the grid. So here we see sorry, gotta of course ban viewbot, ban the viewbot, lock the user, and ban. Cool. Yeah, so this is always not going to be the same size, but we want the actual squares to, do we want them to be the same size? Placeable tiles. Let's see. We're gonna do a pros versus cons for static size. Static size will be the same on each zone. Keeps it more even. Cons will have to figure out how to fit it into our zone. I think we're going to want to do static size. This will help in our modeling and such, and giving us some dimensions that we need to specify, like scaling things down, making sure everything fits within a tile or multiple tiles. But then we need to make sure this plane is the same size as that. So maybe this generates some dimensions. And we start in the top left corner, or so we'll say this is 0, 0 on our local grid, and we'll just build out squares like so. But if, of course, if they're not the same size down here, maybe it overflows a little bit. So that's where, right now I think that could be okay, as long as we manage that correctly, of course. Because, for instance, one thing we might want to think about is back here. So maybe if it falls off of the actual grid, then maybe it doesn't create that object, or that placeable tile object. Okay. Interesting, interesting. Right, let's see, anything new over here? No, and no. Okay, all good. All right. So we want to go static size. We don't want dynamic size. Dynamic size fits the zone, causes more variable sizing. Will not have the same size in every zone, causing overlapping zones to have problems. So we want static size. So what we're going to actually do is create a prefab of our tile, basically. So let's go ahead and do this. Create empty. And we're going to just call this a placeable tile. Like so. And how do we want to denote the size? We can always actually add a plane to it as well. So instead, let's do a 3D object plane. It's pretty huge. Is there a way to edit this? No. Maybe. We're just going to scale this down to 0.1, 0.1, 0.1. Like so. And that gives us a small tile. Like so. We will overlay. Mesh collider, convex is trigger. And you can see, just divides it into that. What it gives us. So. So we're going to call this placeable tile. Is that the size of a cube? That is the size of a cube. So instead of 0.1, let's do 0.25. So. Okay. So there is that. And using that, we can create multiple. So we can just imagine that we'll have a lot of those tiles, and if the tile's able to be placed, then for instance, if we have a bunch of those tiles and they're all not is obstructed, then we can place our object right there. So we'll call this, instead of this placeable tile, we'll call this plane a placeable tile, like so. Scaled down. Might want to create an actual object to have a 1-to-1 scaling. But yeah, so let's look into see if anybody has ever dealt with something like this. Unity 3D, creating a grid over a plane object. Building an interactable. Best way to make a grid system, drawing a 2D grid on a 3D plane. Okay. Let's see. Attempting to draw a 2D grid on a plane, which is my floor, as a sort of game board. Manuscript to generate a texture to render. Color, grid color. Okay. Polar collider, get component. So for grid image width. Okay, so that's kind of what that looks like. Actually, not too shabby. Running, however, does not show my build version. Well, that's actually what I want, believe it or not. So generate grid. For the grid image.width, grid image.height, if x.border size and x is greater than grid image.width, minus border size, y. Set pixel x, y. Okay, so that's actually not instantiating a grid or anything. It's actually just creating some lines and such, maybe? Who knows? Best way to create grid session. Well, I've been messing around with making grid-based building system. I've been looking online, and I've found a couple different ways to make it work. That's what I'm using. Make a grid class that takes in a width and height, and then create a list of coordinates for grid positions. Then getting the mouse position around the nearest coordinate, and that's the grid position you can interact with and instantly shape buildings onto problems. I'm really struggling with thinking of how to make it so that when placing buildings of different size, I don't know how to make multiple grid spaces occupied. Most people do take a width and height and instantiate a game object of a tile, then get when the mouse is over this tile. The problems: while this method is really simple and allows for the ability to place buildings of different sizes, getting the collision of the but it takes a lot of space. I don't like how if I want to make a 100 by 100 grid, I would have to spawn 10,000 game objects. That's fair. This method isn't that great for 3D games either. Which of the methods are the better methods? Okay. What's your design target to speak? Let's see. Grid position is calculated and sorted on a list. Then no, the grid coordinates are not calculated. They are calculated anytime you need them. For example, if you have a 5x5 grid, you place an item on a grid at position then the world plus is calculated by multiplying both coordinates by 5 every time you need it. This costs nothing compared to memory usage and lookup in a list. Okay. If you have to define any point how big that object, you can do that with a grid size component that contains the size and grid coordinates of the contents of the object. The component is missing a 1x1 size can be assumed. Now, let's say that you have a 3x6 size building and you place it. You flag 3 times 6 grid cells as occupied. Before you place it, you check those cells are not already occupied, or you can remove anything that overlaps. The object's origin grid coordinate can be assumed. The one closest to the origin of the grid, i.e. in a corner, could also use a rule to determine the center grid tile. This object origin coordinate is required to correctly calculate which grid positions the objects would/will occupied. This would be unsuitable for the grid of this size. 10K game is already pretty much a 200 would blow it up in the scene. If you add the third dimension, But for mouse selection, however, tile, you can do simple math, convert mouse position to world position on a plane, then convert that position to a grid coordinate. You don't need to do ray casting or use a gain object that responds to mouse over event. On the internet, if you want to show something at every grid coordinate, you still generate a lot of game objects. In that case, you will have to serialize the grid in chunks using your own format, preferably binary, and determine the visible chunks. Editor snap grid size, but it's editor only. There's no untying grid unless you use grid layout class. Okay, so this is where our cursor object is going to probably come in handy. We already have the global position. Alright, so I am thinking, since we want this to be not a crazy game, we're probably not going to want tile object. We probably do want to do that. Oh my gosh, I knew this was going to be hard, but Jesus Christ, this is starting to get a little complex. But once the system's flushed out, then it'll be quite fun seeing it work. Build in midair. Use the ground. Then I could use a tile map. Anything above using. Okay. Okay. Let's see. I have a plane and I have crowd like. Oh my. On draw gizmos. You can, yeah, we can always use gizmos to visualize this. Create a grid. With greater than 100, you will have to learn a couple of things to store and draw things effectively. The best resource when it comes to grids is Reblob Games. Hex map tutorials, C# and shader tutorials. 10,000 is not feasible. You will need to go instancing or other efficient way to display things. Not to mention AI and anything even happen in your game. Okay, so yeah, since we're using nav mesh system, we're definitely gonna wanna store this maybe in like a dictionary of that, and then just get world position on the tile and then triangulate that to a grid, and we can visualize that out by drawing gizmos, but we won't ever actually need to draw that. Do we want to? Because, for instance, we got one of these tiles of 0.25 size, and if that's this size, think about how much game objects that would be. That'd be way too many right there. Okay. Decisions. So we're gonna delete that. Not gonna need placeable tile. Placeable tiles, okay. Using a dictionary to store grid components. Create a class for a grid component. Takes in its coordinates x. We'll do x, y, z, and we don't need z. We'll probably just need x and y, or x, y, z. Yeah, we'll do x, y, z. Has some Boolean values. Okay, so instead of having this, we're gonna go in here to our scripts, and we're gonna create a new scripting object, but we're gonna do a actual. I don't know the difference between these two. Let's check this out. We'll call this placeable tile, like so. Create asset, placeable tile, menu name, scriptable objects, placeable tile, public placeable tile. No, we don't need that. Placeable tile. We're gonna delete that. And this is literally just going to be a C# script as a class. Basically, if you are new to programming, don't know how to program, a class is basically, we're just creating a kind of data structure object for this. Classes can have methods that they can run. For instance, all of these scripts we have written are classes that inherit from a base class called MonoBehavior, which has a bunch of, that's just in the Unity engine. We could go look in the documentation, but I don't think we can actually see any implementation. But they have start and update functions that you can override. They're just put in there. It's kind of, I think it's an interface maybe. I don't know. But we're gonna delete that, and we're gonna literally just create a empty C# script, and we're gonna call this a placeable tile. All right, like so. Let's jump in. So this is a bare bones class. We can use Unity engine in here, but we're not inheriting from anything. So what we're gonna need needs. All right, we're gonna need some variables. Variables. We're gonna need a public integer x, y, z, like so. And those are coordinates. We're gonna need a public boolean is obstructed equals to true or equals to false. So so this is literally just a basic object. What else might we need from the tile? I don't really think we actually need anything. Okay. So there's our placeable tile object. That is very simple. It's literally nothing crazy. But yeah. And let's just set this to 0 right away. And then we can, of course, edit that. So if we go back into our placeable zones, have some Boolean value, and when clicking the plane, we translate that coordinates locally on the plane and then see which placeable tile is closest, and then that's what we check. Okay, so maybe we can think of this like a data structure too. Maybe we can have some neighbors. And we have some rudimentary size that we have to check. Because now we need to make sure that we have a specified size. So of these tiles. And that size has to correspond to the collider as well. So if we grab our placeable object, for instance, see, this is not going to be an actual game object. This is just going to be a data point, basically, on this plane. Create a grid. It's going to be a lot more manageable in memory. Okay. So there is that. And it will have connections to each node that's neighbors. And we just need to make sure that when we're trying to place an object, it kind of like can, like the placeable objects will have a size, and that size corresponds to how many nodes on this grid it's going to need. So let's go in here and think this out. So placeable object will need a size to which denotes, or we'll need a x and y size to denote how many placeable tile nodes will need to be obstructed. Okay, so we know that. So placeable tile. So let's do for now, public list of placeable tiles, and we're gonna just call this neighbors. So, and we're just gonna be equals new list placeable tile, like so. Oh, yes, we're gonna need to using system.collections.generic, of course. All right, so we have that. So every single time, it's gonna be that would be a lot of data, though. So actually, maybe what we can do. So here's some thought process to how we can do this. We can either have each placeable tile have its neighbors that we can index. We can have a dictionary in our zone that ties the neighbors to its next, or when trying to place an object, we just index the node's positioning in the grid by the size divided by 2, up and down. So go both ways, because of course the middle tile that's where the middle of the object will be placed. So whatever tile we're hovering over is where the tile will be placed. And then we need to go up and down and make sure it can fit right there, because we don't want it to, like, you know, kind of like where we're like, so imagine the intersection of my hands is the tile that we're hovering. We kind of don't want it to be like this. We kind of want the tile to be like this, where that's the center point, and then it goes out to where it's there. Okay. So these are some ideas. We're gonna do this as memory intensive, but easy. Not as memory intensive, because these objects are instead, these lists are actually stored in a dictionary, which is one memory object, versus having all these multiple. Not as memory intensive, but still takes a good bit of memory. And that also means for like later, we're gonna have a lot of VFX probably in this game, just to make it a little more wacky. So we want to save as much memory as possible. Probably the best solution. So when trying to place the object, we just index the node's position in the grid by size divided by 2 up and down. So placeable object will have a size in which X and Y needs to go up. We can make it easy on ourselves and make sure that X and Y is always even, so we know how far to go up and how far to go down, or something like that. Actually, maybe having it odd would probably be better, because if we divide it by 2 and then a tail, yeah, who knows? Stuff we can think out later. I'm gonna save all these just because these comments are gonna be pretty important. So we'll comment this out just in case, because it might be just the easiest way to do it. Yeah, so in our placeable zone, generate grid. On start, we want to generate the grid. So using our zone, generate grid of placeable tiles over our mesh. So, let's see. So this is using an image. Generate grid. Floor size equals bounds.size.x and bounds.size.z. Actually, so this is it. So we'll get a vector 3. We'll do plane size, or plane bounds equals new vector 3, and that's going to be not here. Let's see how they do it. So floor collider that bounds size. Okay, so this is where we'll need to get in here. We're gonna have a private collider. Collider. We're gonna do plane collider, and then we're going to at start get a plane collider, and we're gonna do our plane collider dot bounds dot x, comma y is going to be. Let's see how he handles it right here. Okay, that's interesting. Do a plane collider dot bounds dot z, like so. Bounds does not have definition for x and not acceptable bounds you're finding. So that might be deprecated. Oh, that's size. Okay. Okay, cool. So we got our plane bounds right here. 3, X and Y. So, for there, let's see. So for our grid image dot width and grid image dot height. So so that's setting the pixel. So I would like to do this, and this is actually going to happen on start. Let's see, we don't have anything happening here, don't have anything happening here. We're gonna just debug.log our plane bounds. Let's see what our plane bounds are. Oh, let's do that. So, should see. Okay, let me go in here and fix this. I'm getting tired of that. Okay. So we got 40 and 10. So that's actually interesting. 40 and 10. Let's see if that changes when I select, not the mesh, placeable zone. Let's see if that changes. Oh, here we go. So 40 and 10, that would make sense. So let's see what happens if I change 4.5. It's a little bit bigger. Do 4.25. And move that in like so. Actually, probably want 4.15, right? A little bit like that. And that actually seems to fit pretty good. Okay. So 4.15. And now let's try that out. We should see a 41.5, right? Yeah, 41.5. Cool. That is very cool. I like that. So there is our... So this will be our zone. So then we get to decide how big of a placeable tile we want. So placeable zone. How about we have a public int size of tile. And now we're just gonna equal that to 1 right now. We'll have actually this as a float. And why are we putting this as a float? Well, maybe for different zones, we want to have different size of tiles. So if we imagine this scale is 41 by 10. So that means our z-axis up there, this we could think of it could be broken down into 10 right there. But if we wanted 0.5 size of tiles, then that could be broken down into 20 tiles. 4.15. Having a 0.5 there, we automatically might want a 0.5 tile. But we also got to make sure that the scale for each same zone matches. And if it overlaps, then maybe we don't want that. And also, eventually, what we're going to do is probably have to define our own, like, we'll maybe export this scene or make a diner in Blender or figure out how to mess around with meshes in Unity, because we're going to probably want this to be the same mesh, the same object that expands over to, like, right around here. But we will look into that in a little bit. Probably get to it maybe by the end of this week. Let's see if we can actually set up. So, okay. So we got our plane bounds. So let's do for int I is equal to 0. Or we'll do int x is equal to 0. X is less than plane bounds. Plane bounds.x. Then we're going to do an x is equal to x plus size of tile. So that's just going to increment us like so. Float to int. We're going to do actually float. So there we go. So then that will go up like that. So for float y is equal to 0. Y is planes on y. Y is equal to y plus that. Like so. Okay, so this is where we could generate our grid. So what we're gonna do is we're gonna have a private dictionary. Or we could have a private list. Dictionaries are nice and good. We could have our vector3 location. And that points to our placeable tile object. Do we want a list or do we want a dictionary? Probably want a dictionary so we can index it. Dictionary, type key. Let's see, what do we want our key? We probably want a vector3. And then we want a placeable tile, like so. And we're gonna call this grid, basically. That's gonna be our grid. Like so. So we'll do vector3. That's a local position. What to do here? What to do here? Let me make sure. Yeah, it is. Okay. But yeah, let's see what we can do here. So, size of tile is 1. We can make multiple tiles at these positions. Vector3 grid. What we're gonna do is we're gonna do a dictionary. Or no, we're gonna do grid at we want a vector3. We're gonna do a new vector3, and we're gonna do basically, you know, our x, and then we're gonna do our actual. We're gonna do 0, and then we're gonna do y equals new placeable object, and we're going to need to make a constructor for this object. So we're gonna do a public placeable object. So. Need to make a constructor, I thought. And we're gonna, for fuck's sake, new placeable object with int x, y, z. Come on now, x, int y, int z, comma bool is obstructed. Like so. Okay, we're just gonna look up. Here, C# class constructor. Constructors. C. Person. Class person. Public. Okay. Placeable object. Of course not. Placeable tile. Like so. Put that, and then we're going to set x, y, z is equal to x, y, z. Can I do that? No. We're going to set public. Do x is equal to x. We'll do this. This is where this is where that namesake for having underscore variables works. Go back out of insert, and we're gonna go up here. Maybe like so. What way do we like this? That is a good question. I think I'm gonna go like this. Just the underscore or the so x is equal to underscore x. Z is obstructed is equal to is obstructed. Like so. All right, we have our constructor. Placeable zone, new placeable object, and we're gonna have a x. Our y is 0, and our z, or our y, and false. Yeah, it does. It's right here. Not placeable object. That's, I keep doing that. And we'll have our floats here. All right, there we go. And of course I do that again. Like so. Okay, new vector 3. We're making all new stuff. Okay, cool. So now, after we're done, let's do a debug.log grid. Just want to see what we got there. Cool, cool. All right, so let's go ahead and hit play there. Not set reference to an object. Oh, yep, that would make sense. Gotta actually instantiate the grid. Grid equals to new dictionary, like so. On start, because we need to actually create the grid object. Okay. So we got generic. So let's go back into here. Not zombie controller, wave controller. We're gonna disable this. Don't need that. I'll handle that. I'll keep that in there. But this is going to be quite a big amount. We'll do grid dot, or we'll do grid at vector 3. We'll do 0, 0, 0, or we'll do vector 3.0. Like so. And then the debug dot log grid at new vector 3. We'll do plain bounds dot side, or plain bounds dot x 0, plain bounds dot y. Okay, let's see. And then we're gonna do a dot. I don't know. We'll see. That should point us to a plain bound. I mean, two objects. Because that would mean that would be the 0, 0 location and the max location. Oh, yeah. So The reason why is because we go up by 1, so plane miles, we'll do minus 0.5 because we know that. Like that, and y should be fine, right? Yeah, because it goes up by 1. So that will be at 4.1 or 41 now, and that should be okay because the 0.5 is going to cause some problems because we're scaling that weirdly. So we got a placeable tile at 0, 0. Plane bounds on x, x is less than. So. Make sure we get our edge. So okay, so now we have 2 active tiles at the end, so that means our grid is made. If we wanted to see if I can log that, we could see the whole grid if we wanted to go through, but I don't think we need to. So next up, we have this cursor object, and we're going to want this to basically interact with the grid. So if I hover over this point, or hover over the grid at all, and maybe click or something, like while we're in build mode, then we need to return the closest point in that grid. So we could do a simple raycast, and then that raycast gets a point on this, and whatever point is basically whatever point is closest within a certain thing. Alright, I also want to see how these guys interact with. They should walk around this, of course. Zombies are spawning. Let's see. Oh, we still only have 3 coming. Of course. Yeah, they gotta walk around that object. That's good. You die. Maybe we need to have that having an exit time on death, because they can still punch through dying like that. That's not good. We'll go fix that real quick. Transition duration 0, 0. Actually, we'll have a 0.01. We'll have a 0.1 right here from walking and such. 1, but we don't want the punching animation to finish right away. So let's see. Or maybe 0.05, like so. And we also want to make it so it doesn't have to finish. Okay, so that should be okay now. Okay, let me stop this and just, for now, go into our day-night controller, and I'm going to set the daytime to 10 seconds. Just make it really quickly. Okay, that's going to go really quick. Right, yeah, super fast. 10 seconds, bam, already over. Now we're we're spawning our zombies. Like so. Just want to test this nice little break from having to work with the environment. Bam. Okay. Punch. You die. Okay. Don't really know what I'm doing here. Where else are you coming from? Right there. Okay, cool. Okay, yeah, so he would have started punching, but he died there. That's good. That's good. Okay. So, next up, we have our grid created. So, there's our grid generated. Now, basically... So, if we go to our placeable zone, we have a mesh collider, and it's convex, and it's a trigger. Provides context. No, I don't think so. Cooking options. Material, mesh, plane, layer overrides. So we get this. And we have a point. So when we're on the grid, we'll have to basically select return the grid position. And then maybe for now we'll instantiate an object on the grid position and kind of see how that works. Maybe. Okay, let's see. How do we want to do this? Let's see. Unity. 3D. Have a grid on a plane object with a vector 3 location, but no colliders. I want to use a cursor object that when it collides with the plane object, it gets its the plane's planes. Oh shit. Because if we look at our plane object, the actual position right here is right there. So that's 0, 0. And then it goes out like so. Oi, oi, oi. So how do we get that point right here? That'll correspond to 0, 0. Okay. This is a ChatGPT question. I'm not going to lie. I have gone on record saying don't use AI as much as possible. 2 new reasoning models that excel at coding, science. Okay, perfect. We'll try it out. Okay. So, disclaimer. I support using AI as a helper tool. Do not, of course, use it to code for you. You need to learn as this. But what I'm basically going to do is use it to point me in the right direction. And kind of go from there and see how it would work, what it can discern. And we're going to do a really analysis on its code to see if it's even worth it. Okay, so in Unity 3D, I have a plane object with a trigger collider, a cursor game object that points to that is flush with the ground, and on that plane I am generating a grid of placeable tile class objects that, what's it called, that have a local grid position x, y, z, where y is 0, and a boolean using the cursor object, I want to grab the position that is closest to the cursor object and have that as my selected tile. The grid is generated from top left to bottom right, where the local positioning, where the center point 0, 0 for local positioning on the plane is in the middle of that grid. How could I grab the placeable tile object using that cursor using the on trigger enter and having the selected having a selected tile. All right, I don't know how else to ask this. Let's see. It's reasoning this out. Okay. Okay, that's an idea. I didn't even think about using a two-dimensional grid. Probably would be better. Okay, so let's see. Grid selector, float tile size, grid width and height. We don't need actually that right now. Placeable tile, grid, on trigger stay, other compare cursor, world position, other transform that position, local position, transform inverse transfer point cursor that. Okay, so because this grid center is 0, 0, we need to shift our local coordinates. For a grid with an even distribution, the top left cell is at negative tile size times grid width -1 divided by 2, and negative tile size times grid height -1 divided by 2. Okay, so tile size, so negative tile size times, wait, what? Why is it negative? Okay, so I see. Yeah, because 0, 0 is in the middle. Then if we go up to the top left, that'd be increasing maybe however we... Yeah, that would be increasing it, right? So if we do a negative... So calculate the grid indices by dividing by tile size and rounding. We don't want to round it to an int though, do we? Round to int, adjusted. Round to a certain. We would probably want to round to a specified thing. Let's clamp and select the tile equals that. Okay, so this actually does seem like it might work. Let's go ahead and check this out. So what we're gonna do is generate grid, and then on void, we're gonna do an on update. We're gonna on trigger stay. All right, and if other equals not plane collider, we're gonna do if other equals if other dot compare tag And we're going to just do cursor, because we just want our cursor object like that. So that also means that our plane needs to be flush with the ground like so. And our cursor has a collider as well. So we're going to tag this as our cursor, rigid body. We're going to do a collider. We're going to do a sphere collider like so. Scale that down to 0.2, maybe. How small is 0.1? 0.1. No, 0.01? No, 0.1. 0.2. 0.05? That works. 0.05. Okay. And that is a trigger as well. So on trigger enter. On trigger stay. If other dot compare cursor. Like that. Then we need to adjust the world position. So we're gonna get the world position. So vector 3 world. Oh, hey, what's up, a bad witch? I'm doing pretty good. Sorry I didn't notice you there. Yeah, we're just working on a game. We're making a placeable objects kind of. We're kind of trying to figure out how to do that. Basically, right now I have a placeable zone, and we're generating a grid of a custom game, custom object like so. And we're trying to figure out basically how to select one of those current grids. So, for instance, if we kind of look at here, we can see that this oops, accidentally closed that. If we go to our placeable zone script, we can see that we're getting the plane bounds by basically getting our plane collider bounds size.x and .z, which actually is working pretty good. And then we generate a local grid as such, basically keeping a dictionary. Might change this data structure later. And now we're just basically trying to figure out how to select that selected tile and then branch out from there. Hey, what's going on? This is it. Welcome back. Hopefully you just heard all that. Trying to set up basically some placeable zones, placeable objects, and such. This is going to be pretty hefty, kind of a hefty task once, probably be working on for the next couple of days. But yeah, so right now we're going to get a world pause of the object from other.transform.position. I cracked and I asked basically AI to kind of concept this out, and oh, thanks for following, man. But we're trying to I'm basically just trying to like figure out how other people would do this. We're using the new O3 model, and like this would have taken me. Oh, awesome! You joined the Discord. Oh, no problem by narrating. You're all good. Sweet. Yeah. So the Discord, just really run through again. If we go in here, you can go ahead and join the Discord. It's in the description of YouTube, or you can press the thing on Twitch. You'll get welcomed. Basically, once you're in there, you can join the channel. If you just want to be part of the lab, you can join part of the lab. If you want to be part of the lounge, you can join part of the lounge. You could do both, and then you'll get a little lad. But yeah, very simple if you want to participate in that. But yeah, so back to what we're saying is the way it's seeing, this would have taken me probably 2 hours to figure out. So the problem I had kind of figured out is when we're basically trying to get that 0, 0 point, which is going to be our top left. If we just wanted to simply triangulate that using the local position of the object, then 0, 0 is right here. So this would be, if let's say this was size 10, then top left would be like 10, 10, and bottom right would be like -10, -10. So instead, we needed to figure out how to basically get an offset, and luckily with the tools of today, we can figure that out. So this is, I didn't ask it to basically solve the, like, I wanted it to point me in the right direction, which this is definitely pointing me in the right direction, but for instance, this is completely different, and the way its implementation is completely different, but this kind of showed me how I can maybe do that. So for instance, because the grid is centered at 0, 0, we need to shift it according to basically this equation. If we really want to think this out, it's, let's see, the negative tile size, because we create a tiles based on the tile size described here. For instance, we could make tiles smaller or larger based on what objects are going to go in each zone. So if I go back in here, it's just usually set to 1. And for instance, if you are curious about how big a tile would be, so this 1 scaling, that's how I've scaled this so far. We're just getting the colliders, bounds, and such, and 1 scaling for a plane object. This was 10. The bounds was 10, and this was 41.5. So if I set the size of a tile to 0.5, then we'd have a tile at position 41.5, but because it's set to 1, we only have a tile at 41 right there. But yeah, let's get back into it. So we're getting our world position, and then we want to triangulate this, not triangulate, get the local position by it's saying inverse transform point cursor world pause. So convert the world position to the local position relative to the plane, this object. So we're going to, yeah, we'll name this cursor world pause too, because that makes more sense. And then vector 3, local pause is equal to transform dot, let's see what it was saying to do, inverse transform. So inverse transform point, and we're going to get cursor world pause. So this is going to get our local position based on whatever it's called. Also, I'm going to go ahead and do a private selected tile, or not selected tile, we're going to do a placeable tile. And I'm not using a game object for the placeable tiles because I foresee having a very large amount of tiles for placing stuff on, and you don't want to have a like 10,000 game objects just for tiles, because that will eat up a lot of your kind of memory and cause performance issues. So we're using just a standard object, not a mono behavior object class, where it just has these data points and such. Maybe make it nullable. It's not a bad idea. But basically we're just increasing x by the size of the tile here. So if we wanted to, we could do that. But yeah, let's keep going forward. So we're applying some offsets. So tile size, which is interesting. So this is saying negative tiles. This is why you never trust AI. You know, I don't even get really what's going on. So if we do 1, grid width -1 divided by 2.0. So 0, 0 would be at the top, basically. So if we got 0, 0 in the middle, then that would be, let's try to think about this. Make sure this math is right, because we don't want to copy and paste this and be like, why is this not working right away? That the AI gave me. Oh my God. Let's actually reason this out. So if I had my cursor up here, and let's say this was of size 10, then that would be 10, 10, because our object center is right here. So this is up 10 over 10, or this might be, no, this would be negative 10, 10. So if we use this equation, so at negative 10, 10, so this offset, okay, so the offset is the tile size minus the grid width, which would be 10, minus 1. So that's 9 divided by 2. Interesting. Okay, I can definitely see how this works. Because we do the tile side minus the grid width. So if we wanted, if we were at negative 10, 10 at the local position in our X, and we're increasing the grid width, so grid width minus 1 divided by 2, basically cutting it in half, so that's our total. So I am just jumbling here. All right, let's just actually start. Let's set our offsets. So we're gonna do X offset. We don't need to worry about Y because Y is gonna be flush with the ground. So we're gonna do a size of tile. We're just gonna literally do it as they were saying. So our actual size is, this is our bounds right here. So we'll do a plane collider.bounds.size.x divided by 2. So, and float z offset. Chat, it looks horrible if the origin is at the center and the offset is just width divided by 2, height divided by 2, add 0 point or 0 as needed. So yeah, actually that's kind of what we do want. We do want, if the origin is at the center and the offset is, then the offset is just width divided by 2 and height divided by 2. So that's actually would probably be the case, because the way this grid is being generated is we're starting at the top left and then kind of going in a row like that. So since we're using a local position basically as a collider, translating this cursor object that follows our mouse, 0, 0 is actually going to be the center of that grid. That's just the way I was coding it. There's 1,000 different ways you could probably do this, but this is some new territory for me, so we're just kind of trying to figure it out as it goes. So if you guys want to point out anything that might be a little bit better, absolutely would appreciate that. But we're gonna keep on going here, so we're gonna just see how this works. And we'll do 5 by 2. Let's see, not and, obviously. Let me make sure, setting that, yeah, like so. Okay, so there's the offset, and then we're gonna do a float. Let's see, adjusted X and adjusted Z is just adding that offset. Adjusted X equals X offset, or local pause, not minus but plus X offset. And this could absolutely not work, but this is just pointing me in the right direction, hopefully, and it's starting to give me some ideas. And this is the way I can kind of conceptualize figuring it out, because if we go up here, I kind of wrote all this stuff that we need, because we need a static size placeable tile, which is this object right here, and then using a dictionary to store grid components at a location. So we could even index the dictionary to give us the placeable tile that's closest. So we got that. So that's our adjusted X and Z. So we got now, hopefully, something. So actually, we're going to actually see how this works right here. So we're going to debug.log. Adjusted X. Adjusted X. Like so, and then we're going to also debug.log adjusted Z. Give it a little bit of names. Debug X plus, and then we're going to debug Z like so. All right. Now, once our cursor starts interacting with this plane collider, we should start seeing some things and such. Yep, there we go. So if we go to top left, right up here, this should be 0, 0. So not 0, 0, obviously. let's see. See how this is working. So x going all the way down here to 20. Interesting, quite interesting. Got some guys coming for us. So this is obviously not too correct. And this probably is because I'm using the scaling as well. So, using vectors for indexing might be problematic. Clones aren't real and hate you specifically. Very true, very true. But I don't foresee indexing. Actually, I was planning on just eventually, maybe even just having an index as a tuple here. Vector 3 is floats, but of course, because the tiles can be of size like 0.5, we do need to actually use floating or decimal point numbers to index. Right now, we're just trying to get everything set up. Optimizations is going to be in the next phase milestone, basically. I try to foresee as much as I can, but I also want to get it working because that's always fun. So this is not doing shit, of course. And okay, so if we looked up here, 23 and 1Z, let me go look at this again. Because if we're creating a grid of size 41 and 10, basically. So this bottom left corner Z is 25, and this top X, okay, what the fuck? X, so where is 0, 0 for X? Our X scaling does not seem to be, so going up and then going down like so. Okay, so the Z is inverse because Z is only going to be 10, so up here is 0, 0. But what the fuck is up with the X? I'm just gonna let those guys focus on that for now. Because if we go in here, X should... What I was expecting while I'm doing this again is I was expecting this to be like 25 and down there to be like negative 25 or like negative 20 or something. But no. So this should be... Okay, so instead of doing this, we're gonna actually just get our localpos.x and our localpos.z. So that I probably should have done in the first place. Okay, here we are. So if we go here, we can see that's 2, 2, and this is around 0, 0. So if we go all the way up here, this should be, so X is interesting. So, okay, yeah, this is not gonna work. So the problem is because I'm using the scaling, is that the X is scaled a little too far away. So instead, it's still treating it as the X is of the same size. So it actually is treating this as 10 by 10 when using local positions. So let's think of another way we can do this. So we got Z. And I know I don't want to use game objects because that's going to be a little hefty on the memory load. mean... Current world pause. We need to triangulate that. So I'm gonna put the scale back down to 1. Like so. And now, for instance, if maybe... See, now I think if I debug.log the adjusted x, I think now this would probably work. Okay, let's find this object. What the fuck is that? I'm gonna raise this up a little bit. Boop, like that. So if we go top left, adjusted Z is, let's see. So that bottom is 0, 0 right there. 0, 10, 10, 10. Okay, so that kind of does work. We'd have to rotate it a little bit because it goes boop doo doo doo. But yeah, so that's a problem. But of course, I don't plan on using scaling ever. I have never used Unity's like editing the meshes or whatnot. I'm gonna have to go in Blender or something. But I am actually just going to keep working with this because I foresee I need to keep these scalings at 1 because working with scale, especially in game dev, is kind of tricky sometimes. It's not really going to solve any problems that you got. It's just it's good for visualizing things, but eventually you need to probably scale things down correctly. But, okay, so this is actually not doing too shabby. So... if we wanted, let's see, so this is getting the plane bounds and is setting, so I wonder what this grid is doing, because I thought it was going from top left, but it could also be going from something completely different. So let's try accessing that adjusted X. So since we're using scaling, we're going to debug .log. We're gonna debug.log our grid at new, and I know this is very temporary. New vector 3. We're gonna do our adjusted x 0, and then adjusted z at that, and then we're gonna do that dot. We'll just print out that object. No, can't do that. I need to get its actual location. Okay. Let's see what happens when we do this. Alrighty, here we go. If we go over here, this, so giving key, yep. Okay, so we need, of course, clamp this grid, just like x dot, we're just gonna statically cast this to an int. Ay, ay, ay. I do not like this, but I just want to see if this is actually even going to access a correct indice. Okay, so we should make a tile size of 1010, like a grid the size of 1010. Okay, go over here. Okay, yeah, there we go. Now we're getting access to actually some tiles. So here is 0, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like so. So we actually have access to the tiles now. If we clamp it, like using an integer. So what we should actually do is in here, instead of casting it to an int, let's see. So let's think. What we want to do here is we want to clamp the number to a specified size, and that size is our size of tile. So basically round it. So let's see. Let's see. C# math F clamp a float to basically round a number to the closest specified value. Math.round. Okay. So we'll just set our adjusted x equals math.clamp. Clamps the given value between the given minimum float and we're gonna round that. Round to the nearest integer. Can I specify that as size of tile? Couple the grid indexing from the tile size for your own sanity. What do you mean by that? Decouple the grid indexing from the tile size. Cause that's where, like, I'm not actually using a game object with a specified size. Basically, just if you get close, that's kind of what I'm trying to do here, and round it to the like that. Not that round, not round to the nearest integer. It's the near floating point value. Specified floating point value. Florida. Oh my gosh. Find the number by step size to get the index in terms of steps. Add 0.5 to ensure rounding to the next nearest step. This is always fun to learn. Round a single precision floating point value to the nearest integral value and rounds midpoint values to the nearest even number. Maybe clamping is the right thing to do here. So let's look up mathf. Alright, yeah, we definitely want to round this stuff, but there we go. Mathf.clamp. I want to see what this does. Clamps the given value between the given minimum float and maximum float values. Returns the given value if it is within the minimum and maximum range. Returns the given value. Float result between the minimum. So adjusted x. So the value is going to be that. And we're going to want to basically math f dot round. Just index grid elements by their position in the grid, as in the third from the top, second from the left, just 2D array or flatten to 1D if you prefer. Basically, use integer indices. Yeah, no, I see what you mean. Instead of having like a dictionary of using vector 3s, just indexing it, as in like suching like this. Let's do a placeable tile, not placeable object, placeable tile, grid, like so. We could do tiles like that. Yeah, I think that would be a good idea. The problem with that, though, because we have tile size right here, and a tile size, this is just going to kind of be, for instance, I don't know. The way I was thinking about this earlier was using game objects as tiles, because that's what I've done in the past for my basic game, like basic games I've made. But of course, this is going to scale up too big. For instance, deal with the pain of dealing with float inaccuracies. Very true. But that's also where I'm like, maybe we got to expand the grid, because of course it can index it to a different size. Because like, for instance, this is like a basic placeable object that I'm using, and instead of this being like one tile, I want this to be able to basically occupy maybe 4 tiles, to where, I mean, I'm statically making some visualization stuff in the head's not going over too hot. Let's see. So let's just also do a grid, or we'll do tiles at x comma y equals new placeable tile right there as well. Our number of indices expected 2. Motherfucker, what? I'll float to it, yeah. We'll just statically cache that. So now we're creating 2 grids. We'll see which ones I like working with the best. Yeah, it would definitely save me the pain of working with those floating points, because floating points can be a pain in the ass, especially when I like trying to round to these positions. But the problem is, what if I want, okay, size of tile. Do we actually ever need the size of the tile to be like half of the size of the tile? I could always just increase the bounds. Like if I wanted to make more tiles, I guess I could like multiply the bounds tile by it, by like an arbitrary number. If I wanted to make like a 10 by 10 plane, have 20 tiles per row, you could increase that and then create tiles basically like that, because these are going to be locally to the actual object, adjusted with the offset. So inside the offset we would have size of tile, local position. So oh, this is always the fun part where you start delving into stuff you never delved into, especially with game dev, because you start really messing around with math. But yeah, let's see. So using this grid, we're using a vector 3, and using this is we're just using an x and y location. So we could clamp this to integers, which is very simple, as simple as using a tiles at adjusted x comma adjusted z. That's always a float, so we'll just cast that to an int, and that will do the exact same thing on it. Probably will that definitely is better for memory usage. Creates a smaller object. But then that's question, like, I mean, I guess I can see as it goes. Right now, priority is, oh yeah, of course, need to actually create the list as well. Placeable tile of, see, that's the problem. We're also using a array of, okay, so we're just gonna create a list of this. Or no, we don't want that, we want, let's have a size or an array initializer, so now we're gonna do a new array, array list, maybe. No, we want a new array. No, we want the array to, of course, have a size. Size would have to be the plain bounds x times the plain bounds y, so we'll do a new. This is always super fun. Okay, so we'll actually do this in the generate grid. You can use a base object of 1 by 1 units and create a n by m grid on that. You can compute the index by floor local position times grid size, assuming you offset first or just have the origin in the top left corner. Tile size would be implicitly defined by scale, and you shouldn't do physics on that object. Don't do physics on non-uniformly scaled objects in general. Just my 2 cents on possible grid implementations. No, I greatly appreciate it, dude. I'm kind of a junior developer, if you can probably tell. And this is the first time I'm really kind of trying to create my own gridding system, not using game objects, because that would create way too many game objects for me in my scene. And eventually I wanted to kind of handle it like this. So we'll do tiles equals new array, not array list. We'll do a new placeable tile of size plain bounds we'll do plain bounds dot x and comma plain bounds dot z. So, and that is a float, so we need to set comma int, because that should always be an int. This is, of course, just for now. So now we have that list, and we have this, and that will work. Such. Yeah, let me. Okay. Okay, so that's still not set to a instance of an object right here. I just set that to an instance of the object. Oh. God damn it. Love having to figuring out code on the spot. Alright, let's go look at how to create an array in C#. Creating array, like so. Always fun. No, thank you. Size 0. Okay, so instead, equals a new placeable tile. So we want this to be accessed from anywhere. I feel like this should be how that works, right? Creating... Instantiating a two-dimensional array C#. Yeah, we don't want with no pre-existing values. Different default value. Certain loops are less likely. Okay. Motherfucker. Yeah, I mean, it would make sense if I had to set that to an objects of null. But okay, let's take a step back. Take a step back and kind of really think this stuff out, because me mulling over it is not gonna get us anywhere. Like in coding, you always gotta, if you ever find yourself stuck, just take a step back, take a breath, and try to get the bigger picture. So here, we're trying to generate a grid based on this plane size. Oh, that's still running, that's fun. Based on this plane size right here, and have, this is basically going to be where we're allowed to place objects. And within this plane, we want to generate a grid of arbitrary size of kind of the bound size. Right now, it's just, so this is going to just be like a little zone. We want to be able to move the zone to cover our actual flooring object. And the way I thought of doing this is creating a plane object and then eventually extruding these sides to basically cover our area in which we want to be able to allow to place objects that are allowed to be placed in the zone. So we need to generate a grid, and in doing so, we need to be able to access that grid. For instance, if we come up here and placeable tile, this is probably the best solution I could think of. When trying to place an object, we just need to inject the node's position in the grid by the size, divided by 2 up and down. Probably the best solution. So when we select a tile in that grid, if we go up, we're going to only want to go up half of the size, because the middle of that object we're trying to instantiate on the grid is going to be at the middle. Not kind of like this, but kind of like that. So we need to generate a grid for that. So we can get the plane bounds from the size of the collider, which that actually adjusts for scaling. But for now, since we want to use since we need to find a position and tie it to that kind of placeable tile object, and we're not using like specific game object colliders, we should probably keep the scaling to 1:1 so that our local positioning on the actual object stays the same. So in here, we need to create a data structure. So we have a few options. We have dictionary, we have list, and we have arrays. Dictionaries, they're good for accessing things right away, passing in a key value and returning that value, indexing of O of 1. And we have arrays, which indexing, I think, could get up to O of n, depending on, in worst case, but I could be wrong about that. Don't quote me on that. Then we have a list. That's probably be the easiest thing to do, creating a list, but creating a 2-dimensional list. That's just what I've worked with C# too, using lists, but using an array of static size, because who knows? None of this is really helping. Constructor syntaxes, creating an array in C#, You know what? We're gonna just go ahead and make a list. Because I like lists. We're gonna do a list of placeable objects. Basically a two-dimensional list. Like so. And we're going to just instantiate that up here. And now index that like so. Why? Alright, cool. So now we have a list object as well. Excuse me. Yes, that's okay. Never had Visual Studio do that to me. So, working on 1x1 units, is definitely the best implementation, for sure. Creating an invite X grid on that. You can compute the X by floor equals local position times grid sign, of course. Assuming you offset that, so that's where we have the offset right here, and we're already kind of adjusting for that. Let's see if that actually works. For some reason, I doubt it, but who knows? Okay. Index was out of range. It might be non-negative and less than the size of that collection. Oh, that's fun. Oh, yes, right here, because we're doing less than or equal to. And a list. Not doing that. But yeah. And we are also gonna not equal that. We're gonna add that to the list. Am I being an idiot again? Yeah, I am being an idiot because we're trying to access that. Holy shit. Yeah, I am just having some really big shenanigans going on in my head right now. This is impressive, if I do not say so myself. Ugh. Okay. Let's fucking just figure this shit out. So, yeah, I'm not gonna want to use these floats. You are right by that. Size of tile. And this could be just 1 for now. Because who knows, maybe we'll need... Maybe if we want larger tiles, then we could just always scale that up. Okay. Now, we can use a dictionary, because... Tiles is equal to a new list, not a new list. Well, we're going to go back to using array, because we are programmers, and we want to use an array here. Just define that up there. And what happens if I do tiles equal to visible tile of size plane bounds dot size not square magnitude x plane bounds dot z type, which is not. See now. Okay. Replaceable tiles and plane bounds X, plane bounds Z. So now, what if I try to index this? We could, of course, 4 and I. Tiles at X, comma, Y equals. Just do a new placeable tile, like so. Ay, ay, ay. What a nice roadblock. Index was outside of bounds of the array. Let's see, right here? Yes, it was. Because this would need to be -1 right here. Because if spy 5 I time, our top should be 9 9, not 10 10. Okay. What do you mean it was outside of bounds for the array? It's fucking size. What do you mean? It should be the size. For what position do you think it's outside? I'm gonna fucking debug this because we all want to see. This is always great. Got the 0 0, and then after that. Okay, now we're gonna see really what's fucking going on here. Oh, of course not. It's fucking Y. I am literally having a not too good of a coding day today. Maybe should have tried to work on these placeable fucking grids. Probably the most complex system we're going to be building for milestone 1. But once it's implemented, it'll be nice. It'll be very nice. All right, there we go. Yeah, now we're good. Of course. Now I actually don't need to do this. X, comma, adjusted Z. I'm just gonna cast these to end, of course. And then we're gonna round that position because eventually that's what we're gonna eventually want to do. Use our math F to round to positions. But yeah, let's go ahead and hit play here. So X position set. working probably because the collision's never happening. Maybe. Placeable tile. Yeah, placeable tiles all there. Well, let's put dot x plus. No, not dot x. Placeable tile x plus. Bam. Plus. And we're going to put our z there too as well. Make everything look super nice. Yep, yep. Set that down here as well so we can actually interact with our zone. Okay, there we go. We got right here 90, 00, 09, 99. We got accessing to all these positions. Okay, cool. Getting rid of this dictionary. And we're just gonna use that basically. Don't need a dictionary of this stuff. Keep it simple, keep it safe. Alright, so then finally what we're gonna do is a math f dot round this offset like so. And can I put that in int? No. And we can count that as an int. Round to the nearest integer. And since that will be rounded to the nearest integer, we will go ahead and cast that. All right. So on trigger state, now we're getting the position of our on our grid. Now let's see. Next up is actually placing objects on the grid. So we'll need to basically have a building mode and such. That took quite a... Yeah, I'm getting a little frustrated. Might need to take a break here soon. This was, This is definitely... Because I'm also getting some out of bounds. Index was out of bounds of the array. Okay, so we can't round it, of course, to 10. Yeah, for instance, that will go up all the way. Round, we're gonna do not a max math f dot clamp maybe value. Try flooring it. All right, we'll give that a floor instead. So floor. Actually, since we're flooring it, the thought process behind routing is that if we're in like the middle of it, it'd go to I guess the highest one, but we'll see how that performs. And I'm actually gonna just floor this to int, so we're not using any casting. Like so. Kind of done with the. I don't like casting things like such, but that can always be useful. Flooring to int. Okay. There's that. Yeah, we still get index out of bounds right here. It's kind of like because I'm on the edge. Yeah, there's that. Seems to work pretty good. If we're on the edge like that, because it's so high, it's probably gonna floor it all the way up. Kind of like technically it might be even like 10-10. But there we go. So we can access these placeable tiles now. We're accessing them. Slap these guys like so. So now, basically, we're going to have to enter a building mode. And when we're doing a building mode, we're going to want to basically override our swing like that. Because this is, of course, how we're going to place objects. It's using the same trigger as that. But yeah. Honestly, I think this is where I might stop it for today. If you are new to the stream, I welcome you. I'm junior developer, kind of making a game in free time, learning along the way. Hope you guys can learn alongside me. There is a Discord if you guys want to join. I just set up a streaming schedule, so I am on Eastern time. I plan on streaming from 11:30 to 2:30 Eastern time. But I'm gonna usually probably go over that, but especially today, I am just not feeling it after this. The way the channels worked is we have the lab and the lounge. The lab is where we look into technologies. I'll do a lot of game dev during this portion, but we're also going to start looking into some open source projects. I've started looking into some that might be of interest to people. And kind of applying those, researching all that. So I hope you guys stick around for that. And then we have the lounge section. That's going to be later at night. Just variable times where I'm just going to be playing games with friends and such. So if you're interested in that, feel free to stick around with that. But I am going to go ahead and sign off for today. Maybe I'll come back today, but definitely need to take a step back because I was kind of struggling there, as you guys could see. But yeah, like to end the streams with a nice little thing I like to say. Just remember, the good is always out there. It's just one step away. Y'all take care. I will see you guys later.